In this session, we'll send data from our host PCs which will reach at microcontroller at ATmega2560, and after receiving data from this microcontroller, it will return back the same data over the UART to our host PCs. So basically we'll write a program to loop the data on our board, the main controller at ATmega2560, which is having 4 UARTs and one of which UART0 is connected with another microcontroller's UART pin at Mega 16U2 microcontroller, which is exposed over the USB. So while programming, when we try to download our program to the main microcontroller at Mega 2560, so first it is coming to the interface microcontroller via the USB, and this data is again routed via this UART to the main controller, and that's how we are able to program this microcontroller with the help of our host PCs. So this is a basic requirement which is done with the help of this interfacing microcontroller, which transport the data from USB to UART. In our case, we'll use this channel to send normal UART data from our host to ATmega 16U2, and this will transfer to our main controller, and from main controller we'll write program which will transmit the same data which it has received via this UART. So we'll send some data from our PC, it will be received at this interfacing microcontroller, and this intermediate microcontroller will send this data over the UART, and after receiving, as we have programmed this, it will return back the same data over the UART, and further it will be returned to our host PCs over the USB. So let's write a program that will do the same thing. Since we have to use UART0 of main microcontroller at Mega 2560, so to use it, we have to initialize it first. Serial dot begin, and the baud rate, let's keep it 9600. So initialization is done here. Now whenever we'll send from our PC, so it will be received at microcontroller, right? So I'm checking whether the data is available on microcontroller side. So serial dot available. So if this is 1, then just read the data, just name it rx data equals to serial dot read. So it will read the data whatever is available in receive buffer, and after receiving, let's return it back to the PC. So for returning, we have to simply transmit the same data over the UART0. So to do that, serial dot write, and what data we have to write? Rx data, whatever we read. So it will simply check the data whenever it is available, means we are sending from our PC to the main microcontroller, then receive the same data and return it back. Let's connect our board and check whether this is working or not. I'm connecting now. So it has come. Let's compile the code. It is showing some error. Serial dot. It is saying Rx data was not declared. So declare it first. Int Rx data. Now let's compile it. So compilation has done. Let's upload to the microcontroller. It is uploading. Upload is successful now. Let's open now the serial monitor. Now in this serial monitor, whatever will send from our PC to the microcontroller, it will be returned back. That is our expectation, and baud rate is configured to 9600. So let's keep this and just send any string hello world. So we sent, and same thing we received from the microcontroller. Send any other string. Let's sending from PC. Same thing should be written. Now we got the same thing, right? So it is working. We are able to successfully configure the serial port, and same data it is returning by the microcontroller. Let's do one more thing. Let's change this baud rate. Baud rate, let's suppose we are I'm just changing it to 38400. Now let's set something. Sending random data. Now you got some erroneous data. It is not correct because our baud rate is not matching what we have configured. So that's why we are not able to transfer the data over the UART. Even if you set it to 4800, baud rate is 4800. Now again you got the wrong information. Now let's make it Again, the correct one, baud rate equals to 9600. Now we got the exact correct data. That's how the data is transferred over the UART, and we can easily configure our UART like this. For UART 0, we have to simply use serial, and for UART 1 you have to use serial 1, for UART 2 you have to use serial 2, like that you have to use, and internally it takes care for further configurations and it maps to the library. If you want to see that also at library layer, then let me know in the comment box. I'll make a separate video for that, what exactly been done at low level. Here I just explain the overall picture. So in-depth understanding, if you want, you let me know, I'll make a separate video for that. We are having now basic understanding of this ATmega2560 development board and how to program it, and we are having exposure of UART also now. So let's go further and understand about Bluetooth module HC-05. So in the next session, we'll understand about the HC-05 Bluetooth module and how can we communicate and configure this Bluetooth module. Thank you so much for watching this video. Stay tuned and learn more.